Today we're going to look at mergesort. I really think that the crux to understanding this algorithm comes from understanding how to merge two sorted arrays. So we're going to look at trying to merge two sorted arrays before we even look at anything to do with mergesort, and then after that we're going to look at implementing mergesort recursively. And of course we'll step through a full example of how to do it recursively with just numbers and a pencil and a piece of paper. So let's say that we have an array A1, and A1 contains 9, 11, 15, 31, 39, 43. So this is our array 1, and it's a sorted array 0, 1, 2, 3, 4, 5, and then we have an array 2. And then array 2, it's going to be slightly larger than array 1. We have 2, 10, 17, 29, 40, 45, 67, 79. And it's going to have a slightly larger length here. So 0, 1, 2, 3, 4, 5, 6, 7. Now, this is important to understand that mergesort really comes down to getting an array sorted and combining it into a final array that we call temp. So if you can understand how we're going to do this, it's pretty much how you're going to do mergesort. Temp is going to have to be at least 13. It's going to have at least a length of not 13, 14. Yeah, 14, because we have 6 in the first array and 8 in the second array, so we need at least 14 spaces. Oop, I don't want the color palette. It's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 14 spaces there. And this is where we're going to want to place our sorted arrays. So what we're going to do is we're going to start a counter on array 1, I equals 0, and j equals 0 here. And we're going to check to see if A1I is greater than or equal to A2J. So this is our criteria that we're going to check. And if it is, in this case, then we would increment I. If it was the other way around, so say that this is the case, A1I is greater than A2J, then we're going to increment I. And we're going to do the opposite. If A1I is less than A2J, then we're going to insert A2J and then increment J. Alright, so let's go ahead and just step through this step by step. Alright, so for the first one, is 9 greater than or equal to 2? Well, we know that 2 is actually less than 9, so we're going to drop 2 down, and then we're going to increment j, so j plus plus. Okay, so j gets incremented. Is 9 greater than or equal to 10? Well, 9's actually going to be less than 10, so we're going to drop down 9, and then I++. Okay. Now we have 11. Is 11 greater than or equal to 10? Well, 10 is actually less than 11, so we're going to drop down 10, and then we're going to do j++. Okay. Now is 11 greater than or equal to 17? Well, 17 is less than 11, so that's not true. And we're going to drop down 11 and we're going to do I++. Okay. Now we need to look at 15. Is 15 greater than or equal to 17? Well, 15 is less than 17, so we're going to drop down 15, and then we're going to do I++. Okay, is 31 greater than or equal to 17? Well, 17 is actually less than 31, so 17, and we're going to get j++. Now we get j equals 3. Okay, so I'm going to stop writing this over here because now we know the criteria that we're checking, and we're just going to watch. Now we're just going to step through the array until we get to the end, and then I'm going to explain what we're going to do when we get to the end and we have a length of A2 longer than length of A1. Okay, so now let's just step through everything. Alright, so we got 31 greater than 29. Well, 29 is actually going to be less than 31, so we're going to drop down 29, and then we're going to increment j, so j becomes 4. Now you got 31 greater than or equal to 40. Well, 31 is less than 40, so 31 goes here, and now we increment I. Is 39 greater than or equal to 40? Well, 39 is less than 40, so 39 goes here, increment I. Oops, not 43, 5. Just incrementing by 1. Now we got 43 greater than or equal to 40. Well, 40 is actually going to be less than 43, so drop down 40, and then increment j. Is 40 j equals 5. Is 45 greater than 43 greater than or equal to 45? Well, 43 is less than 45, so drop down 43. But we can't increment I. Well, we can increment I, and at this last check, we're going to go through, and I is going to be equal to 6, but there's nothing left. So what do? Well, in this case, this portion of A2 is sorted already. So we're going to end up with 45 and 67 and 79. So we just insert the rest of the array that's left over. So now that we've understood this, we can go on a new level up in abstraction and understand how merge sort is going to work. Okay, so let's use the information that we learned about merging two sorted arrays together to sort this array. Merge sort is important. It's an important sorting algorithm, and it can be implemented recursively. The thing is, we gotta know this thing called a base case is. A base case is when you stop calling your function recursively. It's the ending condition for a function to finally return a value. So for us, our base case, I'm just going to write it over here. Our base case is when we have a subarray of 1. So what we're going to do is we're going to recursively keep on going through and splitting up this array, this array of 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This array of 10, we're going to go through and recursively split up this array of 10 until we just have single subarrays of size 0. So what does that mean? It means we're going to go through until we have 47 left, and 4, and 15, and 35 just by themselves. And then guess what? We're just going to merge them like we did in the last lesson. Because all we have to do is get to a subarray of size 1 and then just go through and merge them sortedly. Okay, so first we got to break this array up. So we're going to split this in half. So this guy goes over here, this guy goes over here. So we're going to get 47 over here, 4, 15, 35, 52, 18, and then we're going to be left with 56, 5, 12, 51, and 9. And so we would check to see if we have a subarray, if we're at a subarray of size 1. Well, nope, we're not. This guy on the left is 1, 2, 0, 1, 2, 3, 4, 5, size 5, and the guy on the right is not size 0. So we're going to have to split this one up. So we're going to get 47, 4, 15, 35, 52, 18. And erase that. Do we have a subarray of size 1 yet? Nope. So we have to split. Let's go over here. We're going to split this guy up. 56, 5, 12, 51, 9. Split this one up. 47, 4, 15. Split this one up. 35, 52, 18. Let's say 18. Split this one up. Now we're actually going to get a size 0. And we did get a size 0 for the first one on the left. Yeah, 56 and 5, and we're going to get 56 and 5, and then 12. So this is a single one. This is a single one. And now I need to split this one up. 56 and 5. Split this one up. 51, 9. Split this one up. 35, 52. Well, we don't need it. This isn't going to split up. That's just 18. And then split this one up. 47 and 4. So at this point we've met the criteria for our base case, and we can start rebuilding our sorted array. At this point, this is right. So now we can start rebuilding our sorted array. Let me get rid of this to make a little bit more room. And I think there's some way for me to change my color here. So I'm going to change my color to green. Now we need to merge these sorted arrays together. So we're going to get 4 and 47. That's a weird 47. Here we go. That looks better. And then we need to do it again, and we're going to merge these two arrays together. So we're going to get 4, 15, 47. We got to merge these two arrays together. We have to merge these two sorted arrays together. It's kind of weird to think about an array of size 0, but it is an array of size 0, and it is a sorted array. So it's just like it's just like what we were doing before, where we were merging sorted arrays together. We're just merging sorted arrays of size 0 together. Keep on writing down the wrong number. 52. And then we need to merge these guys together. 18, 35, 52. Merge these guys together. 5, 56. Merge these guys together. 5, 12, 56. Merge these two sorted arrays together. What is this going to be? 4, 15, 18, 35, 47, 52. Merge these two guys together, and we're going to get 9 and 51. And then merge these two guys together. We're going to get 5, 9, 12, 51. And then we have to finally merge these two arrays together. Bear with me here. It's going to be 4, 5, 9, 12, 15, 18, 35, 47, 51. So that's it. That's all you have to do. If you can understand that we're breaking these down into little tiny arrays of size 0 and then just merging a sorted array together, that is merge sort. Implementing it is a little bit different, and we're just going to look at some crucial parts of the algorithm that you have to understand to put it together. But visually, if you can do this, I highly recommend that you just pick a different array with different numbers and step through it just like this to understand how the algorithm actually works. Okay, let's take a second here to kind of look at some important pieces of the algorithm. So what does it look like to merge two sorted arrays? What does the function for merging sorted arrays look like? Well, depending on whether you want it to be, you want it to return an array or you don't, we could have a function that takes in two arrays and then returns a third array. So let's just say we have a function merge. Doesn't return anything. And we have A1, A2, temp, forgot the type, int, temp. And then we have their respective sizes for array 1 and array 2, n1, int, n2. So we're going to have a while loop, and we have to start our counters for the loop. So we're going to start at the beginning of each array. So int I equals 0, j equals 0, k equals 0. And the criteria that we're gonna check is we want to insert the elements of A1 and A2 into temp under the condition A1 greater than A2. But the thing is, we only do that as long as the sublists are, as long as the arrays are the same size. So the condition that I'm trying to get us to see is that we have to check that I is less than or equal to n1 minus 1 and j is less than or equal to n2 minus 1. Because what this is saying is that, hey, we're under the condition that both of these arrays are the same size. Because once we're out of this, then we just have an array that is larger than the other, and we just have to insert all the elements. So once we're out of this condition, all we're checking is, well, I is less than or equal to n1 minus 1. We're just going to go ahead and add everything left over from A1 into temp. So we're going to use the index counter k for temp. K++ equals A1 I++. Basically what that's doing is it's just inserting the remaining elements into temp. And if this isn't the case, then this while loop's going to go false, and then we're going to check this other while loop, which is going to insert the remaining elements of j into temp. So it doesn't matter if one's larger than the other, because the while loop is just going to fail if it's not. So temp k++, what are we going to have here? A2 j++. So these two while loops take care of the condition where one array is larger than the other. So you can insert all the remaining elements of the array into temp. Now the thing that I kept on checking using, I kept on saying, oh, well, if A1 is greater than or equal to A2, that condition goes in here. Then we're going to place it in the array and then increment I, just like we saw in the example. Else, it means that A2j is actually greater than A1I. We're just going to insert that into the array and then increment j. Kind of a compact way of doing that, but yeah, that would merge those arrays into temp. Alright, now let's look at how we can use this merging sorted arrays together and recursion to create merge sort in C. Alright, let's make a new folder. We'll call it merge sort. And in here we're going to add a new file, merge.c, and a new file, merge.h. So merge.c, let's just make sure everything's working. So hash include stdio.h. We just need the input and output library, and we're going to just test to make sure that everything works. Int main return 0. Save it. Let's make sure that we're in the right directory, so I'm down here in the terminal. So I'm going to cd into merge sort and g++ merge.c-output proc. Now, if anyone is watching this video and they don't know where this g++ comes from, I made a whole entire video that walks you through how to install the GCC G++ compiler onto Windows so that you can access it from the command line. It's in the first video of this series. Alright, everything compiles. We're good. Everything should work here. So before we step into merge sort, let's just get one thing down. Let's just figure out how to create that merge function that we just looked at in paper. So we're going to have a function merge, void merge, and it's going to take an int array, and it's going to give us back a temporary, it's going to modify a temporary array that we're going to use to check our sorted array. And we have to give it bounds to check. So this is different, whereas in the example I showed you, we had I, j, and k. We're still going to use I, j, and k, but we have to use the bounds of the array to figure out where we're starting from. So I is not going to be equal to 0, j is not going to be equal to 0, k is not going to be equal to 0. We're going to start out I at the lowest bound for the first array, j at the lowest bound for the second array, and then k is going to start from the lowest bound of the first array. So we need int low, int up, int low, int up. Okay. And let's make our function, so void merge, in a, int, let's just get all this stuff from up here while I'm typing all this. So I just said this, int I has to start from the lowest bound of the first array, int j has to start from the lowest bound of the second array, int k has to start from the lowest bound of the first array. And now we're going to just check the condition that we had before, where we were seeing if I was less than or equal to n1 minus 1 and j less than or equal to n2 minus 1. But we don't have n for array 1 and we don't have n for array 2. So what are we going to do? We're going to check to make sure that I is less than or equal to the upper bound for the first array. So up 1 is basically n1 minus 1. And I is less than or equal to j. J is less than or equal to not n2 minus 1, but up 2. So it's the same exact thing, except we're checking an upper bound. And then the criteria AI greater than or equal to AJ. So this is where I kind of like, this is kind of like where I stopped in the last video, and I said, oh, let's just take care of the last two cases first. So we can do the same thing here. We're gonna take care of the last two cases. So when A1 is larger than A2, we're just gonna insert the remaining part of A1 into temp. So if we're gonna check while I is less than or equal to up 1, we're gonna insert the remaining part of A into temp. And then we can actually just copy this because we're going to do the same thing for J. And this is not going to be an I, it's just going to be a J. So we took care of the two last cases where the array is larger than the subarray. The two split up subarrays where one subarray is larger than the other subarray. Okay, now we're going to come back up here and finish off this case. So if AI is greater than or equal to AJ, we're going to insert K plus plus equal to AI plus plus. And if it's not, that means that AJ was less than AI. So we're going to have else temp k++ equals a j++. Great. So now we have merge implemented. This is our function for merging the arrays together. Now all we need to do is, why don't we get the code for adding an array, letting the user add an array and all that stuff from shell sort, because we already did that. So we're going to need this part, right? We want to get the elements that we want to add to the array, and we want to let the user enter the data. So I'm going to copy this. This was from shell sort, and if you don't have it, just feel free to copy the code here. So we want the user to be able to enter that. And we're going to get the code to print out an array. It's really simple code. We're just going to loop through the array until we get to the size, until we hit the size of the array. We're going to print out all the elements. And we're just going to need a few things here. So we're going to need to have the size of the array. We've got to have a couple of local variables here. So int n, we need that. And we need an array a, and we're going to add an enumerated type max. So this isn't defined yet either, so we need to go up here and define the enumerated type max. We always, well, I say that I'm getting in the habit of using this more frequently because that's just what we're doing. So a max comes from, it's an enumerated type. We use this all the time when we make an array. So this gives us an array of size 100. All right, and the one function that we haven't added to this is merge. So we just got to add a function for merge sort. Sorry, we have to add a function for merge sort. So let's declare. If you want, you know what? If you want, why don't we why don't we add merge sort up here? Void merge sort. What is merge sort going to have to take in? It's going to have to take int a, and it's going to take in a lower bound and an upper bound. And we're going to have to implement this function where we check to see if we're at the base case of the upper bound equal to the lower bound. That means that we have a subarray of size 1. That means we have a subarray of size 1. So void merge, just copy this from up here. Void merge sort. So let's find the halfway point in the array. I'm going to use the mid. And then we have to create a temporary array that's the same size as A. So temp max. The base case that we're checking is when the lower bound is equal to the upper bound. If it is, we're going to return. Otherwise, we're going to calculate the midpoint of the array. So what is that? That's the low plus the upper divided by 2. That's the halfway point. And then we're going to keep on recursively calling this function over and over again. So first we're going to call it with the low. So this is going to go from the lowest bound to the halfway point. Then we're going to call it again going from the halfway point plus 1 to the upper bound, just like we saw in the video. A mid plus 1 to the upper bound. And we're going to merge So those functions are going to get that's going to get called recursively over and over again. And then finally, once this is done, once this function is done, we're going to return. We have an array of size 1. Once this function is done, we're going to return. We're going to have an array of size 1. Then we're going to merge the sorted arrays together. So temp, low, mid, mid plus 1, up. So at this point, we're going to merge the subarrays together. Now we need some way to transfer the contents of A to temp. So why don't we make a function to transfer the contents of A to temp. So we're going to make a thing called copy, so void copy. It's going to take an array A, and then we're going to transfer the contents of array A into array temp. And to do that, we need the lower limit of A and the upper limit of A. Okay, so that's defined up here. Now we just got to implement it. So for int I equals low, I less than or equal to up, I plus plus, copy the contents of temp into, I think I was saying copy the contents of A into temp, but we're going to copy the contents of temp into A. All right. So now, last thing, we're going to just copy everything from temp into A, right? Because this is going to be our sorted array at the end, and then we just want to copy the contents of that into A. So A temp low up. All right, I'm pretty sure that's it. Now here's the beautiful thing about calling merge sort recursively. All we have to do is just call it up here with our array A, the lowest bound being 0, the highest bound being the size of the number of elements in the array minus 1, which we get from the user. Right? The user is going to tell us how many elements they want to enter, and they're going to enter all that data into the array A, and then we're just going to merge. We're going to run merge sort on that from the lowest bound to the upper bound, and then we're going to print out the array. Let's go ahead and print out the array before we do that too. So I'm going to copy this code. I'm going to put it above merge sort too, so we can see what we entered and what our sorted array is. That's a whole lot of code, so there might be a problem here. We'll find out. Yep. Okay, forgot a semicolon on line. That's line 59. So Control G, 59. So if in Visual Studio Code, you can go to the line where the error is by pressing Control and G at the same time. So I need a semicolon here. Let's save that. Let's try and compile it again. I'm so surprised there aren't more problems with that. It's a whole lot of code. All right, now let's run the program. So enter the elements you like to add to the array. Let's go with 5, and we're going to put in 12, 3, or 2, and then 3, 15, 6. There we go. So if you want it to be sorted from greatest to lowest, then you want to use this condition when you're merging the two sorted arrays together. If you want it to be sorted from lowest to greatest, we just gotta turn this thing around. Recompile it. Five, 12, 3, 2, 4, 13. There we go, lowest to greatest. Alright, so I hope you found this video informative, and I encourage you to
try and change the way that I did this, take these functions, take these loops that print out functions, take these loops that print out the array, turn it into a function, take this thing and turn it into something that just gets data from the array. And then, another challenge here, there's a way to call a function from C using Python. So try to figure out how to do all this stuff in Python, and then just running mergesort on it, and then graphing the result in Python. I'm not going to do it, but it can be done, and it's a really good way to learn how to work with other languages other than C and calling C functions outside of it. If you like this video, like or subscribe. I'm always putting out videos on C. All right, have a great day.